Hey guys, Chapter 10, Projectile Motion is what we're going to be talking about today. Now this is motion going in 2 dimensions, alright, as you can see here in the pictures, some examples of that. We're going to ignore air resistance just to keep things simple for us, alright. So if the projectile is shot, thrown, launched, however it is, it will move through space with only gravity affecting it. Alright, its own inertia, which we know is measured by its mass, will be what propels it forward. Alright? Keeping that in mind, let's look more at these 2 dimensions. Alright? This is probably the most important slide right here. Alright? What's happening in the vertical direction is completely independent of what's happening in the horizontal direction. Alright? Keep them separated. Alright? So we've got to use our vector knowledge to figure out what's going on here. Okay? So these vertical arrows represent the vertical piece of the velocity. These horizontal arrows represent the horizontal piece of the velocity. The lighter colored blue ones that are going at angles, that is your total velocity, which can be calculated using the Pythagorean theorem, which they mentioned in chapter 5, I believe, right here. Okay? Now let's think about this. Gravity is the only thing acting, right? We're ignoring air resistance. Gravity's it. That means that these arrows in the vertical are going to change their length, right? Because here they get smaller on the rise because gravity is doing what? Slowing them down. Then it stops at the top so it can start falling back down to Earth. Now we see the arrows start getting longer because now you're accelerating with gravity. Alright? The object's speeding back up. Alright? This is the same thing we learned about in free fall. Right? So everything you learned about in free fall you can apply to your vertical motion here. Alright? Now horizontal motion. What do you notice about these arrows? They are completely constant. No change. No different. Which makes sense, right? There's no forces acting in that horizontal direction, so velocity stays the same. Alright? Now we can use our velocity definition of distance over time to figure out how far downrange, right, this range, this horizontal distance, to figure that out. Right? But you may need to use that free fall equation that I will show you, remind you of later, to figure out that time. Right? So there's all different things we could figure out with projectile motion, because 90% of what happens in the world is in 2 dimensions or 3. Okay, so here's some different ways that the projectiles can be launched. So at an upward angle, at a downward angle, or straight out and then gravity catches it and here we go. Okay. So here's that vertical distance, right? So this is reminiscent of what you saw with free fall, right? When you get to the same level, you're going to have the same speed, right? Losing by gravity, right? Decreasing by 10. Now we're increasing by 10 because we're going back with gravity. All right? Here's your free fall equation, right? 1/2 gt squared, g being gravity. Okay? So all that's old hat. Well, let's think about this horizontal distance. Alright? There's how we can figure out the horizontal distance. Vx, alright, the subscript x to remind you we're talking about just the horizontal here. Alright, distance over time. Alright, that horizontal distance is often called range. Now the cool thing about that is you can have 2 different angles that you throw a projectile up with. And as long as those 2 angles add up to 90, you're going to have the same range. Right? For example, if we throw a ball upward with a 30-degree angle, it's going to land right here. Well, if we would have thrown that ball with a 60-degree angle, look at that, boom, it's going to land in the same place. 30 plus 60 gives you 90. Right? So the same thing could be said for 15 and 75, 30, 60. Alright, anything that adds up to 90 is going to give you the same position. Alright? Now, vertical height, as you can see by these graphs here, is going to be completely different, but your range will be the same. That's pretty cool. Alright, so make sure that you keep the vertical and the horizontal completely separated. Alright, I don't want to see anybody telling me that we've got gravity acting in the horizontal. Alright, big no-no there. No forces, no acceleration in the horizontal. Okay, this is all stuff that you've learned previously. Now we're just putting it together. Alright, so read your chapter up to the end of projectile motion. Right? At the end of your chapter, it'll start talking about orbits and such. We will not go there. Alright, so it's really just the first half of the chapter. Read that, do the tutorials, watch the videos I've plugged in here. Alright, as always, come and find me if you have any questions or shoot me an email.